Have you ever eaten outside at a restaurant under one of those heat lamps? They can be pretty cozy on a chilly night. Maybe you've heard of tanning beds. Supposedly, they're harmful to your skin. Both of these types of lamps expose us to radiation. But why is one considered warm and cozy and the other is considered dangerous? Each lamp emits particles of light that we call photons. The outdoor heating lamp exposes us to infrared or IR radiation, whereas tanning beds expose us to ultraviolet or UV radiation. So what makes UV photons more harmful than IR photons? The difference is the amount of energy each transmits. UV photons have up to 100 times more energy than IR photons. If we were to translate this into the macroscopic scale, you could think about photons traveling from the IR heating lamp to your skin as like being hit with 10,000 soft foam balls. On the other hand, UV photons from the tanning bed are more like being shot with a paintball. You can trust me on this one. No need to fire one at me. How do we know this? Well, chemists have found a way to measure the different amounts of energy in these different types of photons. The energy of a photon is represented by the formula E equals h nu, where E is the energy, nu is the frequency of the photon, and h is Planck's constant, a value that helps us link the frequencies of photons to their energy levels. But wait a minute. Isn't frequency related to waves? Yes. Light is considered to have wave-particle duality. That is, light exhibits behaviors that are both like a particle, in this case a photon, and like a wave. The frequency of a wave is how fast it oscillates. Another attribute of a wave is its wavelength, which is the distance between the crest of each wave top. Wavelength and frequency are related to one another. The shorter the wavelength, the higher the frequency, and therefore, the higher the energy of the photons. The longer the wavelength, the slower the frequency, and the lower the energy of the photons. One way to think about this is that as the wave gets more wavy, the frequency increases. And as the frequency increases, so does the amount of energy. While we can feel the effects of both IR and UV radiation, we can't see these types of radiation because they sit outside of the visible range of light on what we call the electromagnetic spectrum. This is the entire spectrum of wavelengths of photons running from long to short. Visible light falls in the middle of the spectrum, with wavelengths in the 700 to 380 nanometer range. On the left of the spectrum, we see things like radio waves and microwaves, which have much longer wavelengths and smaller frequencies. On the right of the spectrum, we see X-rays, which have much shorter wavelengths and higher frequencies. Okay. So we talked earlier about how different types of electromagnetic radiation interact differently with matter, like our skin. Let's take a closer look at what I was talking about. I've put an IR bulb into this lamp, like you'd find in one of those outdoor heat lamps, and a UV bulb in this lamp, like you'd find in a tanning bed. Why is one pretty safe and the other one potentially dangerous? The IR lamp that I have my right hand under has a slightly longer wavelength and lower frequency than visible light. It has just enough energy to keep me warm. This is why we often use IR light in restaurants to keep food from becoming cold. The UV lamp that I have my left hand under has a slightly shorter wavelength and higher frequency than visible light. If I keep my hand here too long, it can do some serious damage. This is why tanning beds are considered dangerous. But what's happening at the atomic level to the molecules in my skin when each one of these different types of radiation hits them? Under the heat lamp, each IR photon gives a small amount of energy to one of the molecules in my skin. The energy in an IR photon is enough to get the bonds in these molecules to vibrate, but the molecules remain intact and no damage is done. It's like a gentle heat massage. The UV lamp, on the other hand, is much more intense. Each individual UV photon has the energy of 10,000 IR photons. When one of these UV photons gets absorbed by a molecule, it excites the electrons in that molecule and can break chemical bonds. Excessive amounts of this UV interaction can cause a sunburn that may even promote skin cancer. This applies to everyone, no matter your skin color. Interestingly, the sun emits both IR and UV light. The IR component will give you that warm feeling, while the UV component can give you a painful sunburn if you aren't careful. So, if you're planning on taking a nap at the beach, be sure to stock up on hats, protective clothing, and sunblock. It acts as a protective barrier that blocks UV photons from hitting your skin.